Alright, we're here at gotomath.com. Let's go down to Algebra, and looks like we need to scroll down a little bit because we are now down here at, no, we're not quite there, linear inequalities. So let's take a look at this one right here. Alright, bring up the marker board. Okay, so remember, check means for this checkbox right here. I guess I do need to add instructions on what's going on down here really for the answer. Sometimes we have two different answers. We have the one that we want to put in the checkbox, which is actually equivalent to the answer to another answer, and the reason we do that is sometimes it's kind of difficult to insert our answer at this point in time the way it actually displays here. So we kind of write it in like you would if you were typing in a calculator. Anyway, so we have, what do we have? Find the solution to the inequality is what it said. So of course I've got something simple here. Now in the previous section on finding the solution to a linear equation, the equation means there's an equal sign right here. This is an inequality, and it means there's an inequality here, like a less than or greater than or possibly greater than or equal to. Okay? Alright, so that was kind of drawn out. Anyway, if we have x minus 73, so I've kind of worked on my marker board here the other day and utilized what's called the quadratic curve and trying to smooth these lines out, and I think I did a pretty good job. Okay, so this is just like if you were solving an equation. What we're going to end up doing here is we're going to add 73 to both sides, and so we can say this now, that 0 plus 73, what is going on? I don't want any problems. Don't give me. Okay, I don't know what happened there, but anyway. So we're adding 73 to both sides. Is what we're doing here. All right, add 73 to both sides, and so as you can see here, this is going to cancel out and just become 0. And so now we have x is less than 73. So what exactly does this mean? This means that for this inequality right here, if you choose a number that's less than 73 and you were to plug it in right here, let's say for example we chose a number that was 70, right? 70 minus 73. Now we want to make sure that this is a true statement here, and that is that 70 minus 73 is 0, right? And of course, obviously, this is definitely less than 0. We end up with what? -3, and -3 is less than 0. Okay, so this is the solution set, and another way of writing this is we could write it like this. This is negative infinity, and this would be 73, and we want to make sure we put a parentheses right here. Put a parentheses, because a parentheses means we don't include the 73, and that is because there's not a line under here saying this could be x is less than or equal to 73. This just says x is less than 73. Okay, interval notation here. I think I got one or two problems maybe that ask for this, but probably need to do more than that, I guess. Anyway, so there you go. Pretty simple, just like solving equations. There will be a twist to this, something a little different than if there was just an equal sign there, and you'll have to, I guess, watch until we get to that point. Okay. Where are we at anyway? X is less than 73. So I think if we come up here and just said X is less than 73, let's see what it says here. correct. All right. You can also go up here and just click on that. Alright, so you know where we're at. We're down here at gotomath.com. Come on by, check it out. See you later. Alright, we're over here at gotomath.com. Let's click on the algebra and go down to linear inequalities. And of course, 1.1 was kind of a drawn out video there. So we'll try not to do that again. Alright, it says find the solution to the inequality, and actually it's not just one solution, but it's an infinitely many of them. Yes. So we have, I want to work in blue. Let's work in that color there. Alright, so we have x plus 53, and that is greater than 13. Greater than 13. And so we want to solve for x over here, and of course what we're going to be doing is subtract 53 from both sides. Alright, we'll just, how about we do this? Put the 53 here. Subtract 53 from both sides. And so now we end up with x is greater than 13 minus 53. And let's see. Oh, okay. Negative 40, I believe. Negative 40. X is greater than negative 40. So if you chose a number that was greater than negative 40, like for example negative 39, and you were to plug it in right here, it should be greater than 13. Okay. Now another way of actually writing this solution set is an interval notation, and that's going to end up being x is greater than negative 40. So we would put negative 40 here, comma, to infinity. And of course you always put a parenthesis to infinity because that means we can't ever reach infinity, right? And we don't include negative 40 because this is not an equal sign including an equal sign under it. So we use a parenthesis here. Okay, so on the number line, which I haven't actually done, let's say for example this is 0 and this is negative 40 here, and we wanted to actually draw a picture. We would put like a parenthesis here, or sometimes it's an open circle. Okay, and then of course it's everything to the right going in that direction of negative 40. Alright, so a couple different ways of displaying our solution. But I think up here we just say x is greater than negative 40 and hit here, correct. You can always come up here to the top and see what it's got to say there. Alright, can't figure it out. Okay, so we're over here at gotomath.com. Come on by, check that out, and I'll see you later. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to linear inequalities, and I believe we're doing 2.1. Click on the marker board there. It says find the solution to the inequality. Of course, is the form we're looking for when we want to insert it into the checkbox. That's the reason the word is checked there. Okay, well let's just go on down and get this thing worked out. So what do you think? We'll do that. So we have 26 x is greater than or equal to this time 104. 104. Okay. Alright, so the way we're going to deal with this is we're going to multiply both sides by the reciprocal. And the reciprocal of 26 is 1 over 26 to both sides. So just like we were treating this just like if it were an equal sign right here. Okay, so 1 over 26 times 26 is 1, but we're not going to write that 1. We're just going to write x, and I meant to actually change the color back, is greater than or equal to 104 over 26, right? And so we need to reduce this down here. Okay, so I think that might be 4. 4, 6 is 24. Yeah. So we have x is greater than or equal to 4. X is greater than or equal to 4. So remember, we've got several ways here that we can actually express this. And of course, if we had a number line, trying to write a straight number line, let's say this is 0 here on the number line and 4 is located right here. We could put a filled in dot, let's use a different color here, and say that x has to be greater than or equal to 4. So it'd be everything going off in that direction to infinity, right? Sometimes they put a parentheses right here, an open parentheses. Actually, this would be a closed parentheses because of it includes 4. It includes 4. And then another way, of course, of writing this is we'd write a bracket 4 to infinity, just like that right there. Okay, so several different ways here of expressing that. Alright, x is greater than or equal to 4. So let's, x is greater than or equal to 4. Let's hold our breath. Should check out, right? And of course answer x is greater than or equal to 4. Alright, so come on by GoToMath.com, practice that, and see you later. Okay, we're over here at GoToMath.com looking at some linear inequalities. Let's click there. Go to 2.2 and bring up the marker board. Find the solution to the inequality. Alright, so let's take a look at this. Now this one here is going to be slightly different than what we've been doing, so hang in there. So let me go ahead and just rewrite it. So we got negative 76. X is less than or equal to 1672. Alright, probably wondering, why is it such a big number over there? Well, let's see if you can figure that out. Okay, so we have this negative 76x. So what we're going to want to do is, of course, multiply through by the reciprocal of this number here, because we want to get a 1 here in front of x, right? Okay, so we want to get a 1. So let's go negative 1 over 76 to this side, and then negative 1 over 76 to this side over here. Alright, and a lot of times we put something here in parentheses because of this negative sign right here, indicating that's a negative, and actually it's not that, minus that. Okay. Alright, so we have a negative times a negative, so this is going to cancel out to be 1. So we end up just rewriting this x. But here's the deal. When we multiply through by a negative all the way across to both sides, we must flip the inequality to greater than and equal to. You see that? We've got to flip that thing. And then, of course, we end up with negative 1672 over 76, right? And so we're going to want to simplify that down. I can guarantee you it's going to be an integer. All right, so let's think about what that would simplify down to. And well, let me help you out here. X is greater than or equal to negative 22. Negative 22. Okay. Now remember, we've got several different ways we can display this solution, and that is, let's put 0 here, and we'll say that negative x is greater than or equal to negative 22. So we'll say negative 22 is there. Been using red. Now it's equal to, so we're going to include it, right? So it's going to be a solid dot and then everything to the right of that, right? So no matter what number we pick to the right of negative 22, if you took this and plugged it into the original, for example, let's look at this up here. If you plug 0 in, right, what's going to happen here? Well, we're going to get 0 times negative 76, which is 0, and 0 is less than or equal to, it's less than 1672. See that? So no matter what you plug in over here to the right, it should be make that a true statement. And of course, the other way we can do this is we're going to include, let's go back to our original color. We're going to include negative 22, comma, and then out to infinity. So this will always be a parentheses when we're writing infinity here, okay, whether it's on the right or left. All right, but we use a bracket because we include the number, and that's because of this guy right here. Okay, we're including. All right. Okay, so x is greater than or equal to negative 22. Check that out. X is greater than or equal to negative 22. Correct. It would be terrible if that said not correct, because then that means I'd have to redo this video. So we got x is greater than or equal to negative 22. Alright, enough said about that. Okay, so you should be catching on by now. We're here at gotomath.com. Come on by. See you later. Alright, linear inequalities. I think we're doing 3.1, I believe. Find the solution to the inequality. So there we go. So we have 11x plus 19 is less than 195. Less than 195. So we want to isolate x and get x by itself. All right. So that means we're going to get rid of this 19. So subtract 19 from both sides. Be the first thing we want to do. And then of course we can rewrite 11x is less than 195 minus 19. Let me think about that for a second. Okay. Alright, 176. 176. Alright. Now, we want to get a 1 here. Of course, we're going to multiply by the reciprocal. And that means we're going to multiply both sides by 1 over 11. Right? 1 over 11. Okay. So these guys here are going to cancel each other out, and there will be a 1 left. So now we're left with x is less than 176 over 11, and of course we're going to want to reduce that down. What we got on that? Okay, scroll down here. X is less than 16. Okay, so let's draw a couple pictures here. I'll draw at least this picture. X is less than 16, so of course I'm going to put 0 here. Here's 16. Now, we don't include 16, so I'm going to put an open circle here. And it'd be everything less than 16. Right? And we can always go up here to the top and check that out. For example, an easy one always is 0. Plugging 0 in, and you can see barely up here at the top. If I plug 0 in up here, this would end up being 19. Yes is less than 195, so that's true. All right. Another way of writing this is, I think I'll just do that right down here, and meant to change colors. So this is negative infinity, and of course 16, And remember, we don't include 16, so we put a parentheses here. Alright, interval notation. Okay. Alright, x is less than 16. Less than 16. See what we got on that. Correct. Go up here, click on the answer. Correct. Okay. So we're over here at gotomath.com. You can come on by, practice. See you later. Okay, we're over here at GoToMath, kind of zoning out. We zoned out. Let's do literally inequalities. 3.2. This is like take 3 or something. There's been like some kind of mess up every time I do this. Find the solution to the inequality. 3.2, is that? Okay, just making sure. And why is that showing that? There we go. I did not want to have to restart this again. Okay, so quickly, let's get rolling here. So we have 19 x minus 7 is less than 126. Less than 126. So we're going to add 7 to both sides. Add 7 to both sides. So now we're left with 19x is less than 133. I don't know, what is it, 133? Is that right? Can't add all of a sudden. See, take 4 away from that, give it to that, that's 133, okay. And now we multiply by 1 over 19 to both sides. The reciprocal, because we want to get a 1 here for the coefficient of x. Right? 1 over 19. And so now we're left with x, no need in putting a 1 there. And 133 over 19 should reduce down to what? What the heck is that going to reduce down to? Reduce down to something. Yeah. Okay. Should reduce down to that. Let's see, 27. No, it's 63. Okay, yeah. So we got some other ways of kind of describing this. We can draw a number line. I always put 0 on the number line. And of course, here is 7. Now we don't include 7, so let's not include it. We'll put a circle here. And it's everything to the left of 7, right? Everything to the left of 7, okay? So that's one way. We could do interval notation, okay? Negative infinity up to 7, and we don't include it. So we just put a parenthesis. So that's your solution set to the inequality up here. Right? So if you were to plug 0 in, you would see that negative 7 is less than 126. I guess, where are we at here? X is less than 7. We better check that out. X is less than 7. So time to check the scripting, correct, and answer is correct. Okay, everything looks good. So come on by gotomath.com, practice, see you later. Alright, we're over here at gotomath.com. Go down here to linear inequalities and 4.1, which you couldn't see on the screen there. Alright, bring up the marker boards. We have some drawn. What do we got going on? These things are starting to get a little bit more complicated, aren't they? So let me rewrite this out. So we got negative 103. I guess we'll use black. is greater than or equal to 12 and x minus 14 and plus 17. So I'm really excited about my marker board here. I had to try to refine it ever so often and got rid of the jiggles out of the writing using the quadratic curve, I think it was, JavaScript offers. Anyway, I'm sure you wanted to know that. We've got, what do we got going on here? Okay. Let's distribute this 12 across. Now the idea here is we want to get our x on one side and the rest of the stuff over to the left. All right. And actually this problem here, we've got a couple different ways of doing this, and usually I get rid of constants first, and maybe I should probably do that. So let's go in here and erase that because we can. And I'm going to take this 17 and take it over to this side of the inequality. So if it's positive and we move it over here to this side, then it becomes minus. All right, so that's the way I see it. And then we have greater than or equal to 12 x minus 14. All right, and of course we'll go ahead and simplify that down. That looks like negative 120, doesn't it? It looks to me like. Okay, so we got negative 120 is going to be greater than or equal to, and let's just go ahead and distribute this 12 across. How's that? So that's going to be 12x, and then 12 times 14 is negative 168. Negative 168. All right. And then, of course, let's get rid of this 168. We can move it over here to this side. So I'm starting to kind of skip all those intermediate steps. Plus 168. Because it's a minus over here, we move it over here, the sign changes. Greater than or equal to 12x. All right. So that looks like that's going to be negative 114. I mean, negative 114. That's a 168. What did I don't know what I said. What did I say? I don't know. Negative 120 plus 168 is 48. Yeah. Should have known that. Greater than or equal to 12x. Now we want to get rid of this 12, multiply both sides by its reciprocal. Okay. And so now we're left with, and of course 12 or 48, or 12 goes into 48 4 times. Alright. Now I'm going to rewrite this where my x is over here on this side. So this becomes x is less than or equal to 4. It's kind of more of a standard form there. Alright. So a couple different ways we can say this. Of course we can say it that way. X is less than or equal to 4. So let's just put 0 here on the number line. Let's place a 4 right here. And we're going to include 4, right? Because we got the inequality here, the equal sign. And it's everything less than or equal to 4. So going off in that direction. And then, of course, let's write this interval notation. So we got from negative infinity to 4, and we put a bracket here because we include 4. So hopefully you're catching on to this stuff. X is less than or equal to 4. Alright, X is less than or equal to 4 let's hope that's right. Click the answer. Okay. Alright, so we're over here at gotomath.com. Come on by, practice. See you later. Alright, we're over here at gotomath.com. Looking at the linear inequalities. 4.2 is what we're working on. Let's bring up the marker board. We need something drawn. So we have, what do we have? Alright, let's just write it out here. We've got 17 times x minus 1 plus 17. You know what? I think I need to change my font size. X minus 1 plus 17 is less than 68. So we want to isolate this x, and the best thing to do at this point is let's take this 17 to the other side, and that means we're going to subtract off 17 to both sides. So we end up with 68 minus 17. Alright. So we have 17 x minus 1 is less than 51. Okay, to this side. Let's distribute that 17 across. So we have 17x minus 17, and that is going to be less than 51. So now let's get rid of this 17 and add 17 to both sides. After a while, you just look at this and take it to that side, right? And sign changes. I mean, that's the fastest way to do that. And so now we have 17x is less than, what do we have, 68 on this side? 5. Yeah, for some reason I can't add all of a sudden. Now let's get rid of this 17. Well, we're not going to really get rid of it. We're going to turn it into a 1 though. A little magic trick. 1 over 17. So, alright, so this just now becomes x is less than, and of course 68, we all know what that is, divided by 17. I mean, that's pretty easy, right? That's 4. I'm sure you knew that off the top of your head. Alright. So let's go ahead and draw our number line. We'll just label 0 here, 4 here. Now we don't include 4, so I'm going to put an open circle and then sketch out everything less than 4. And I guess I better continue to use black here. Alright, so we go from negative infinity to 4, and we don't include it, so we put a parentheses right here. Alright, don't forget. Okay, x is less than 4, so let's go up here, check that out, and it looks to me like I needed to change what it said in that box. Can't believe I haven't done that. I don't know why I didn't do that. Alright, let's check that up there. X is less than 4. Alright, it all looks good. And we know what that means. So we're over here at gotomath.com. Come on by, check that out. See you later. We're at gotomath.com. Click on Algebra. Let's go down to linear inequalities. I'll tell you, I found this free software, believe it or not, from Microsoft that you can do screen recordings with. It's only it'll record up to 10 minutes. You can purchase the version where you can record an infinite number, I guess, of minutes, but I don't know about infinite, but anyway, 10 minutes is enough for me. Anyway, it's really nice, and I've been searching forever for some decent screen recording software. Now, at one time I did have probably the best on the market out there. I can't even think of the name of it now, but it was like $300. But that was on another computer about 4 years ago. Anyway, this looks like what's going on here. We need to, it looks like, get this guy, bring him over to this side, right? And the reason for that is because 22 is larger than 14, right? 22 is larger than 14. And let's just do that. So we have 22x minus 14x, okay, is less than or equal to 13. Alright, less than or equal to 13. So because this is a positive number, we take it to the other side, it becomes negative. So this is just kind of a trick, right? We don't want to have to do all those intermediate steps every time. It would actually be nice, 8x, that I can write my own software, my own screen recording software, and so maybe that'll be the goal this year. I don't know. Alright, so let's now multiply both sides by 1/8. I mean, once you're able to write software, man, you can do anything you want, right? Once you're able to learn how to do that stuff. If you want to really do some fancy stuff, though, you need to learn math. There's no doubt about it. Your math skills will come in handy when you want to write all kinds of complicated software. Anyway, x is less than or equal to 13/8. It doesn't look to me like that's going to break down any. So let's go ahead. We'll put 0 here. 13/8 here. So there's an incentive on learning your math. And then of course it says less than or equal to, so let's fill in that dot and everything to the left of it. Right. Now let's go ahead and write this in interval notation where we have negative infinity up to 13/8, and we are going to include it, so let's put a bracket there. Don't worry about what's going on over here. That's actually measuring our path distance, and I can't remember. Oh, that's got something to do with the quadratic method, canvas method. Anyway, what are we doing? X is less than or equal to 13/8. Let's check that out. X is less than or equal to 13/8. Let's do that. Let's click there, correct. Alright, so we're doing this just to make sure I'm checking the script there, less than or equal to. Okay, looks good. So come on by gotomath.com, check that out, and I'll see you later. Okay, so we're over here at gotomath.com, getting the basics out of the way. We're doing linear inequalities, 5.2. Well, I don't know if you want to call it the basics. Find the solution to the inequality. What do you think? I guess black's not too bad, huh? So we have 4x minus 13 is less than or equal to 11x. What was that noise I just heard? Hold on just a second. I got some strange noise on my phone. Oh, it's Cody Keys, the next president of the year. Crap, I forgot. I'll call you in the morning. You need a... Cody Keys, remember that name. He'll be the next president someday. Yeah. Okay. Anyway, I shouldn't probably say his name on here. What the heck? Where are we at? So 11 is bigger than 4x. Well, 11 is big. Oh man, he's a guy, alright. 11 is larger than 4. Now I'm being serious about the comment I made just a second ago. Very serious. Let's bring this over to the right hand side. So we have minus 4x. Yes, I'm extremely serious about that. I'm sure there's people out there like, who gives a crap? Get on with this video, would you? I got a test in the morning. 7x. Probably do. Sorry about all that. He had a test at one time. Yes, he did. We got him an A in finite. So he owes me. Alright, so we got negative 13 over 7. Whoops. How did we do it? It was simple. The solution to making an A in a math class, it's called, here, let me spell it out for you. If I spelled it right. Practice, practice, practice. Here I'm going to write it 1,000,000 times. Right, so this is up to the, let's say, 1,000, whatever. Right, practice, practice, practice. That's how you make an A in a math class. You practice. Alright, enough said. X is greater than, and I'm going to write it in the more standard notation. Whoa, that ain't right. Yeah, you practice. How many people asked me that? Mike, how do I make an A in my math class? It's called practice. So the goal was, we're going to do that problem 65 times. So that's kind of the big deal with my website is it's got like, every problem's got probably 100 different combinations. And the reason for that is, actually some have more than that. The big reason for that is to practice, practice, and practice. I mean, that's it, That's how it's done. Understanding, of course, is a huge part in math. Because the more you understand it, the longer you're going to remember how to do it, right? And you can apply it to the real world. We got to fill this dot in right here because this is greater than or equal to. Right, so let's not forget to do that. Yes, understanding is a huge part, plays a big part in all that. You can sometimes practice things all you want, and basically what that means is you have memorized some algorithm, but you really need to understand it. All right. Since I've spent too much time doing all that, we're going to just look at that. X is greater than or equal to negative 13 over 7. All right, looks good. Talk to you later. See you later. I got to talk to Cody. Bye. Alright, we're over here at gotomath.com. Click on the algebra. Let's go down to linear inequalities and let's look at 6.1. I believe that's what we're looking at, isn't it? I think. I hope. I hope so. Things are all starting to look the same after a while. At least to me they are. Let's do this one here. So we have 15 x minus 5 is less than or equal to 7x. Alright, less than or equal to 7x. So we're going to need to probably distribute that 15 across. So we got 15x minus 15 times 5 is less than or equal to 7x. Less than or equal to 7x. Now you notice that the 15, right, it's a larger coefficient than this 7. So that means we're going to take this over to this side. Let's take it over there. And because it's a positive, when we take it over, it becomes negative. So we're going to rewrite this stuff. So we have 15x minus 7x. I think I'm wearing out my bamboo tablet here. And then, of course, 15 times 5, what is that? That's 30, 60, 75, 90, 100. What is that? 25, 35, 15, 5. Yeah, I think it was one of those numbers. Now, because it's a negative, when we bring it over to the right-hand side, it becomes positive, right? So let's just do that, 75. And then, of course, we've got 15 minus 7. And I think we all know what that is. 8x less than 75. Alright, hopefully I haven't made any mistakes. Let's multiply the reciprocal to one side, 1 over 8, times 1 over 8. And what was that noise? I don't know if you heard that or not. Phone's making some crazy noises. 75. Of course, let me tell you something. It'll be coming up in the next year or so. There's going to be all kinds of devices out there that's going to be talking to us. As soon as I implement this artificial intelligence, you know, right now we're hearing noises, but they'll be talking to us here shortly, I promise. This right here doesn't break down, right? What is it? Well, wait a minute. 75, no, let's see. Wait a second. No, that didn't break down to anything. Okay. Yep. Anyway, let's go ahead and draw this number line. I'm ready to get this problem done. So here's 0. We'll say 75 over 8 is down here somewhere. And we are including it. So we want to put a circle and fill the dot in because we're including it. And it's everything to the left. Correct? Because it says less than and equal to. Let's go ahead, do the integral notation down below here. So we got negative infinity, and then we got 75 over 8, and we're going to include it, so that means a bracket right here. So it includes it, okay? X is less than or equal to 75 over 8. So let's hold our breath and hope that is correct and it looks good. Click on that, make sure that's good too. It all looks good. Alright, we're over here at gotomath.com talking trash. I'll see you there. Bye. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to inequality 6.1, 6.2. That's what we're doing. So we're finding the solution set of these crazy looking things. They're getting a little bit more complicated, aren't they? Alright. So we have 10x is less than or equal to 14 times 12x minus 20. So remember, we're trying to isolate x because he's been a bad boy. Right. Or maybe we'll say that's the x and she's been a bad girl. Whatever you want to do. Alright, so let's go ahead and distribute this 14 across the x. You know, maybe this is the reason why divorces are really up. People are just solving for x a lot in their life. I don't know. The possibility, I guess. I don't know why I put a parentheses there, but I did. Could we blame failed relationships on mathematics? It's a conspiracy going on out there. It's a possibility, I suppose. 14 times 12, we all know what that is, 168. Should know that in our sleep. $168x minus, and of course 14 times 20. Heck, we all know what that is. That's 280, right? 280. Alright, let's look at this. 10. Oop, 10's smaller than 168. So let's take this over to the right hand side, and when we do, because it's positive, we take it over and it becomes negative. Well, while we're at it, let's go ahead and take that over to this side. Let's do that. And so we end up with, oh man, we end up with some issues here. I can see it already. Yeah. Alright, let's, ooh, don't hit that. I about cleared the problem out. That wouldn't have been good. Okay, draw black there, okay. So we end up with 280 is less than or equal to 168x minus 10x. Alright, so we got 280 is less than or equal to 158. I think I can do that one in my head. I'm pretty sure. Okay. Now it's time to multiply both sides by 1 over 158. Alright, we've got to get this guy, get rid of that guy somehow. So 1 over 158 to both sides. So now we're left with, I guess what we can do here is go ahead and simplify that down. Sounds like a good idea. And it looks to me like 2 is the only thing that goes into both those guys. So this is going to end up being 140 over 79 is less than or equal to x. And of course I've been writing it in the standard form where x, or I'm calling it a standard form. X is actually greater than or equal to 140 over 79. And we've been writing the interval notation. Let's put 0 here, and we'll just say 140 over 79 is right here on the number line. Since there's really not a scale, what do we need to do? Let's get some red here. So we're including the number. Alright, so let's put a solid dot. X is greater than or equal to. So everything greater than or equal to it. Alright. Now, go ahead and do this interval notation. So we're going to put a bracket here. 140 over 79 and then to infinity. There you go. Alright. 5 minutes on this problem. My God. X is greater than or equal to 140 over 79. Alright, looks good. Okay. So we're over here at gotomath.com. Come on by, check it out, practice. See you later. Okay, we're over here at gotomath.com. Let's go down to linear inequalities. And I believe, okay, I think we did that one. Alright, I think we're on 7.1. 7.1. Let's go to the marker board. Find the solution. Alright. And, so let's rewrite this. We have x minus 7 over 3 plus x, and that's less than or equal to 16. Less than or equal to 16. So we're trying to isolate x. Best thing to do here is we're going to multiply both sides, or multiply across, all the way across by 3. And that means we're going to multiply everything by 3 all the way across. And the reason for that is we want these guys here to cancel out. Let's get rid of this fraction stuff. Okay. So this can be rewritten now as x minus 7 plus 3x is less than or equal to, what do we got, 30, 48? No. Yeah, that's right. 48. Okay. We can take, let's take this guy over to this side over here. And of course, when we do that, right, this is a minus, we bring it over, it becomes positive. And I should have went ahead and consolidated my x's, but I didn't. So 48 plus 7. I guess is a good idea I didn't do that. So collecting like terms, 1 plus 3 is 4, at least the last time I checked. And of course 48 and 7, I think we all know what that is. 55. 55. Alright, multiply through by the reciprocal, so 1 over 4 to both sides. This problem actually turned out to be pretty easy, it seems like. 1 over 4. And now we're left with x is less than or equal to, what's going on there? Didn't want to write. 55 over 4. And that's 55 is 5 times 11. So that's not going to break down any. Alright, so let's just draw us a number line here. I think should be doing arrows on both sides. Alright, let's just say that this is 0 here, and we'll say that this is 55 over 4 right here. Okay. Now, x is less than or equal to, so we'll put a solid dot, and everything less than or equal to going off to infinity in that direction. Let's go ahead and do interval notation. So from negative infinity up to 55 over 4. And let's close the bracket off there. Alright. Okay, so try to save some time here. We'll just hit the answer, let you type it in the box. Actually, that needs to be fixed. X is less than or equal to 55 over 4. Okay, looks good. Okay, we're over here at GoToMath.com. Come on by, practice. See you later. Alright, we're over here at GoToMath.com. Click on the Algebra. Literal inequalities, 7.1, 7.2. I think that's what we need to be looking at. Looks a lot like the last problem. Maybe not. Alright. Well, actually it does, I think. So we have, what do we have? We have 4x minus 6 over 11 plus 12. X is greater than 5. Greater than 5. Okay. Alright. We need to do something with this 11, and the best way to get rid of that is multiply through all the way across by 11. And I think we're going to do that, except unfortunately, one thing in advance, because I'm going to write 11 in here. So I can write 11 over here, that's okay. Times 11, how's that? Alright, I should have been thinking there. Those guys cancel out. What are we left with here? We're left with 4x minus 6 plus, we have 12 times 11. Now 12 times 12 is 144, so this has got to be less than 144. How do you like that? Less than. So it's going to be 132. So I just know that off the top of my head. 132x is greater than, and of course that's going to be 55. I think we all know that. Let's consolidate, collect up our like terms. We've got 132 plus 4. That would be 4, 5, 6, 136. 136x x is greater than 55. Let's take this and bring it over to this side, and of course if it's a minus, we bring it over, it becomes a plus. Take my word for it. I'm telling you it'll happen. Alright, 136x is greater than 61, I'm betting. Alright, now let's get rid of this 136. We do that by just multiplying both sides by 136 to both sides. The reciprocal. Alright, and what are we left with? We are left with x is greater than something, 61 over 136. And the question is, will that simplify down? Well, there's kind of a key in there that says that it won't, but we're not going to get into number theory in this class, but you should take it. So we got 0, and we'll say that 61 over 136 is right here. Now we don't include it, so put just a circle here and everything to the right of it, right? Make sure we do that. And what do we got going on here? So we got to open parentheses, 61 over 136, comma, to infinity and beyond. That's what Buzz used to say. I don't know if you know him or not, but anyway, whatever. What are we doing? Oh, we're going to check to make sure that the script was correct. X is greater than 61 over 136. Yes, everything looks good. And if it looks good, you know what to do. We're over here at gotomath.com. Come on by, check it out. See you later. Alright, we're over here at gotomath.com. I just have to say that. Linear inequalities, I think we're doing 8.1, somewhere around in there. That looks like that's it. Marker. Okay, so, well, if you didn't understand it mathematically, I went ahead and spelled it out for you. Just kidding. No, really, I did. 8 times the number increased by 2 is less than 10. So let's transform that into some mathematical equation or inequality. Inequality, right? 8 times the number. We'll let x be that number. So 8 times the number increased by 2, right? That means we're going to add 2 to it, is less than 10. Less than. There we go. So you should have seen this in the previous section on linear equations. Anyway. Okay, so that's where we're at. We want to solve for x, basically, is what we want to do here. Alright, so let's take this 2 over to this side, so this becomes 10 minus 2. And now we're left with 8x. And taking that 8 diagonally down, I guess we can go ahead and simplify that down, right? To 8. Take the 8 diagonally down, 8. What do we got going on now? We got x is less than 1. X is less than 1. And of course, I've been doing this. Okay. We might as well continue to do it. We want to put a open circle here because we don't include 1, right? And it's everything less than 1. Of course, we can also say this. Negative infinity up to 1. Let's put a parenthesis here because we don't include the 1. Right. X is less than 1. I guess we can come up here and check to make sure this is working properly. It's been told correctly, correct. Let's go ahead and click on the answer here. Alright, so come on by, practice. I shall maybe see you there. Bye. Okay, we're here at GoToMath.com. Click on the Algebra. Let's go down to linear inequalities. And I believe we're down here at 8.2 for the second time or third time or however many times it takes, I guess. Okay, we got 22 times the number increased by 3 is greater than 14 times the number increased by 19. Alright, well, let's write this out mathematically. 22 times the number. We're going to let x be that unknown. So 22 times x increased by 3 is greater than 14 times the number. So we don't know what that number is, so we'll let it be x, increased by 19. Alright, so we want to solve for x in this problem. First thing I'm going to do is get my constants all to one side and get all my like terms that involve x all to the other. And the best thing to do here is we'll just take 3 over here, and then we'll take 14 over in that direction or whichever order. And the reason we're doing that is because 14 is less than 22. Alright, so this way we don't deal with any negative numbers. So we have 22x minus 14x is greater than 19 minus 3. Okay? So we have 22 and 14. Let's see, what is that? So 8. Is that 8x? Is that right? 8x is greater than, and I believe that's going to be 16. Should be. So then what we'll do is multiply both sides by 1 over 8. And so we're left with x is greater than 2. X is greater than 2. So we go ahead and draw a number line. Let's put 0 here. We'll say 2 is here. And we got an open circle, right? Because we don't include 2. And everything greater than 2. And so let's do interval notation. We're going to go from 2 to infinity. Alright, pretty simple there. Let's go ahead and click the answer. X is greater than 2, which you can barely see it on the screen. And I think I'll just, whoa, that looked like a capital X there. X is greater than 2. See, make sure that's all working out correct. Okay, it all looks good. Anyway, we're over here at GoToMath.com. You can come by, check that out, and I'll see you later. Alright, we're over here at GoToMath. Let's click on Algebra, go down to Linear Inequalities, and I think we're looking at 9.1. 9.1. Alright. I think I might need to actually change that. What that actually said was not that. Find the solution set. So you see, this is how we're going to write this. See how this is? X is greater than 1 and less than 2/3. Alright. So really what we've got is we've got two separate problems here. We've got 13, go ahead and write this one out, is less than 6x plus 10. So we've got this one here, and then we've got 6x plus 10 is less than 21. Alright, we've got two separate problems going on here. So go ahead and take the 10 over to the other side. So we're going to have 13 minus 10. is less than 6x, and so that looks like a 3. Bringing the 6 diagonally down, and so what we have here is x is greater than a half. X is greater than a half. Okay. Go ahead and do this side now. So we have 6x is less than 21 minus 10. So then we have 6x is less than, what have we got, 11? Is that right? And so we have x is less than 11 over 6, which is just a little less than 2. Okay, so in a sense, this is an AND statement. X is greater than a half and x is less than 11 over 6. And of course we can write this, actually I think what we've been doing is drawing a number line. So let's just go ahead and do that. So x is greater than a half, so I'm going to go ahead and say the half is here, 0.5, and then this is 1 point something or another. X is less than, so we'll say this is 11/6 here. Alright, so it doesn't include the half, so we'll just put a circle, and it doesn't include the 11/6, but it's everything in between, So in interval notation, we could write a half, comma, 11/6, like that. Alright. Okay. So in other words, we could also say x is greater than a half and less than 11/6. I think that's how I actually have the answer. Let's come up here. Yeah, x is greater than a half and less than 11/6. Anyway, I'll let you type that in there. Alright, so we're over here, gotomath.com. Come check that out, and I'll see you later. Okay, we're over here, gotomath.com. Click on Algebra. Go down to Linear Inequalities. And I believe we are here, which I think I need to change that. It said something about a coffee company. That was in the last section. And I didn't mean to do that. Actually, that's what I meant to do right there. I think I meant to hit the marker board actually. So we have 15 is less than 8x plus 10. This looks a lot like the last problem. Let me see here. No, I think that was a minus sign, wasn't it? Crud. Huh. Anybody see any difference? Oh, there's the difference. The way it's written. I knew something was up with this problem. Okay. Let's just clear the marker board. That's what the difference is. It's the way it's written in interval notation here. Alright. Okay. I was thinking I might have made a mistake on the programming or something. Didn't left something out. Alright, so we have 19. So I guess we'll practice this problem again. Plus 7 is less than 23. So remember, we're going to split this problem up into two separate ones. Focus on the 19, which is less than 3x plus 7, right? We'll focus on that. And then we'll look at 3x plus 7 is less than 23. Alright, and then look at that one. So we have 19 minus 7, bring this over to the left-hand side, is less than 3x. Alright, so we want to bring that over, trying to isolate x, and because it's a positive, we can bring it over, and now it becomes negative. Okay? So 19 minus 7 is 12. Is that right? 7, 8, 9, 12. Less than 3x. We can take that diagonally down. So we have 12 over 3 is less than x. Okay. Alright. So we end up with x is greater than 4. Alright, let's look at this one here. So we have 3x. Let's bring that 7 over. And so we have less than 23 minus 7. So that becomes 3x is less than, and what the heck is that? I can't think all of a sudden. 16. I think that's it. And then take the 3 diagonally down. 16 over 3. Okay. So we'd write this as x is greater than 4 and less than 16 over 3. And of course, we'll look at a number line here. So we got 4 here. And of course, this number's got to be greater than 4. You did something wrong, right? So 3 goes into 16 how many times? Well, we know it goes 5 times because that would be 15 with a remainder. So we know it's at least 5 point something. So we know it's going to be to the right of that. If that was less than 4, something's fishy. Okay. Now we don't include 4, so we'll put a circle here, and we'll put a circle here, and it's everything in between. And so therefore, we can write it like this: 4 comma 16 over 3. Bam. Right? Bam, bam, thank you, ma'am. Answer. And the answer is 4 comma 16 over 3. Alright. There it is. That's a comma there, and it's red, of course, as you can see. But when you see this actually in the browser, when this is uploaded to the web, this whole thing is red, so don't ask. Anyway, where are we at? Tell you where we're at. We're at gotomath.com. Come on by, practice. See you later. Okay, we're over here at gotomath.com. Trying to do something. We're here at linear inequalities. I believe we're at 10.1, so let's just click on that. If I can find it. There it is. Found it. Marker board. Alright, so we'll go ahead and rewrite this. We have negative 5. Let's see, we got 4x minus 19 is less than 23. Alright, so we've been kind of breaking this up into 2 separate problems. Well, that got a little out of hand there, didn't it? And we'll do this side first. Okay. What are we going to do? Alright, let's take a look at this here. We got this negative 19. We'll take it over to the other side. So we have negative 5 plus 19 is less than 4x. Okay. So what do we got going on here? Let's see. What is that going to be? 14? 14. There's an x there. Alright, multiply both sides by 1/4. And so we end up with 14 over 4 is less than, what do we got going on here? Just an x, right? So that looks like that's going to be reducing that down to 7/2. So x is greater than 7/2. Okay. X is greater than 7/2. Alright. And then on this side we're going to have 4x minus 19 is less than 23. So we have 4x is less than 23 plus 19. Right? So we take it to the other side, makes it a positive. So we have 4x is less than, so what do we got going on here? 2, 3, 42. Does that sound right? I hope that's right. Let's see. 9 plus 3 is 12, right? 12, yeah. Okay, let's quick guess in there. 42 over 4. Okay. Let's see. So that looks like that's going to go into that evenly. Let's see. That's 2 times 12. No. That's 2 times 21. Right? 42 over 4. 7 and 3. No, that doesn't break down all the way. 2 goes into 4 2 times. 21 over 2. Okay. X is less than 21 over 2. So you're probably better at that stuff than I am. Alright. So let's just do a number line here. So we have x is greater than 7 halves. We'll put 7 halves here. And less than 21 over 2, which is 10 point something. And that's a 3 point. Okay, let me make sure. 21 over 2. And so we don't include it. So we got circle here, and everything in between. Right, so we have 7 halves, comma, 21 over 2. Okay. Alright, so it looks to me like that's just the way they want the answer there. Let's hit that. 7 halves and 21 over 2, I believe. Make sure, yeah. Okay. So this is how I've written the answer, but you may be asked to write it like that at some point in time in your life. So you'll know. Alright, we're over here at gotomath.com, practicing our algebra, and I'll see you later. Okay, we're here at gotomath.com, linear inequalities. I think I need to update that. We're doing 2.2, thank goodness. We're done with this section, at least for now, as it stands. Alright, find the solution set, round to 1 decimal place if needed. So I had to throw one of these in there, in the mix. It had to be done. It had to be done. We got negative 0.6 is less than 0.5x minus 1.8, which is less than 2, Right, so like the other problems, we break this up. Negative 0.6 less than 0.5x minus 1.8. Okay, so let's take that over to the left. Negative 0.6 plus 1.8 is less than 0.5x. Alright, so we need to come up with this guy right here. So this looks like 1.2. Is that right? I hope that's right. 0.5x. Okay. And then, of course, this becomes 1.2 over 0.5x. Right. 1.2 over 0.5. 1.2 divided by 0.5 2.4. Alright, anyway, I could do a lot of things with that, but we'll leave it at that. So x is greater than 2.4. Alright, let's look at this side over here quickly. So we have 0.5x minus 1.8, and that's less than 2. So we're going to end up with, and I'm going to skip a step or two here. So 2 plus 1.8 over 0.5. Alright, so 2 plus, I'm just going to type that in up here. Alright, what do we got? 7.6. That's what it says. X is less than 7.6. Alright, so we got both those guys. So we do a number line, and we'll just label 0 right here for the heck of it. So we have 2.4. Now we're not including it, so we'll put an open circle. And then we'll say that this is 7.6, even though this may not be to scale here. And everything in between. Right, so we'd have 2.4 comma 7.6. Right, if we were asked to write it in interval notation. But I think actually answer is going to be like this. Less than 7.6. Okay. Oh, wait a minute. I guess it wasn't. I didn't notice. It's too late now. Anyway, well, we'd have had it anyway. 2.4, 7.6 was written in interval notation. I thought, let me do something here. No, that's what it says. Okay. Anyway, we got it. We're here at GoToMath.com. Come on by practice. See you later.